Alright, math folks, here we are at section 3.4, the parallel lines and the triangle sum theorem. We're on page 7 of your chapter 3 notes, and we are going to split this section up into two parts. So this is part 1. We're starting off here with the triangle sum theorem. This starts with an idea that you guys have known for years, that the sum of the measures of a triangle can be 180 degrees. So we look at our little picture here, and you can say that the measure of angle A plus the measure of angle B plus the measure of angle C has to be 180. And they're going to use that idea in several different ways in this section. Alright, moving on to page 8. Alright, example 1 wants us to prove that that is true, that all angles are going to add up to 180. So we drew ourselves a triangle here. We have a straight line across the top that's CP. And we're going to want to show that the angles add up to 180. So the only thing that's given to us here is going to be triangle ABC. See, there's no marks over here showing anything is congruent. There's no marks showing over here that anything is parallel. So that's about the only thing that's given to us. And we're supposed to prove that they add up to 180. So we're going to show that the measure of angle A plus the measure of angle B plus the measure of angle 3 is 180. See, we did not have angle C there, because if you say angle C, we don't know which angle you're talking about. So the one we're really interested in here is angle 3, so that needs to be a 3 there. Alright, and here we go. I know most of our proofs start off with what is given. This is one of those rare cases that's not going to start off that way. We're going to say line CP can be drawn so that angle 1 is congruent to angle A. Right, so we're talking about line CP here. We're saying we could have picked any angle whatsoever to draw that particular line. We're picking to draw it right at the spot where angle 1 and angle A are the same measure. And just like our start is unusual here, our justification is a little bit unusual. This is the protractor postulate. We learned that one a while back. That was a postulate that had a couple different parts. It talked about straight lines are going to be 180. An angle that doesn't open up at all is going to be 0 degrees. Things like that. Well, if we just showed that 1 is congruent to A, angle 1 and angle A, you could think of those as alternate interior angles, because you have a line here and a line there. You could picture line AC as a transversal. So those are alternate interior angles. So if 1 is congruent to A, that means those two lines have to be parallel. So line CP must be parallel to segment AB. Well, we just made the transition from knowing that alternate interior angles are congruent to saying the lines are parallel. So what we just used right there is the converse of the alternate interior angles theorem. Well, now we know that line CP and segment AB are parallel. Think of the things on this other side here of the diagram. You have angle 2 and angle B are also a pair of alternate interior angles, because now CB is a transversal. And if you know those are parallel, like we just said in the previous step, guarantee 2 and B have to be congruent, because they're alternate interior angles. So angle 2 is congruent to angle B. Now this time we didn't use the converse of the alternate interior angles theorem. We used the actual alternate interior angles theorem, because we start off this time knowing that the lines are parallel, and we concluded that alternate interior angles are congruent. So this time we just used the regular original theorem. If you look at the top of our diagram, angles 1, 2, and 3 all adjacent to each other, and together they form the line that's CP, that is line CP. So guaranteed that these three measures are going to have to total 180 degrees, because they add to a straight line. So the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 has to be 180. And what is our reason there? That's going to be the angle addition postulate. Right? That's the postulate that says when you add up the parts, you get the total. And also there, if you wanted to, you could mention that we use the definition of a straight angle. Definition of a straight angle, because that's the part where we came up with knowing that the fact that they have to be 180, because a straight angle is 180. Right, on our next step here, keep in mind that we're trying to show that a plus b plus 3 is 180. Well, we just showed that 1 plus 2 plus 3 is 180. So we have 180 degrees sitting where it needs to be, and measure of angle 3 where it needs to be. But over here we have 1 and 2, whereas up top we have measure of angles a and b. Well, we can get rid of the measure of angle 1 and replace it with angle A, because in step 1 we said that those two angles are congruent. So we're going to say the measure of angle A and measure of angle 2, we'd rather see the measure of angle B here, and we're allowed to substitute one for the other because we just said in step 3 that those two are equal. So we're going to change that to the measure of angle B, and we're going to leave the measure of angle 3 and 180 where they're at, because that matches what we're trying to prove. And sure enough, we have a plus b plus 3 is 180, and that's exactly what we're being asked to show. So if we're at our fifth and final step here, all we need is a reason. Well, we got rid of 1 and replaced it with a, and we got rid of 2 and replaced it with b, because we knew those two things were equal. So we just used the substitution property there. And I know we've had lots of examples where you could use the substitution property or the transitive property, but this is not one of those cases. That right there is straight up the substitution property and cannot be confused with the transitive property. Alright, so we start off with just any old triangle. We proved that those three interior angles have to add up to 180, so that proves that it works all the time. And we're going to do a little project a little bit later that has a more concrete way of showing why that's true. Alright, move on to example 2. You've got a little diagram here. It said figure out the value of x, y, and z. So right away you can see that there are actually three triangles here in the picture. You have a small triangle on the left, you have a medium triangle on the right, and then you have the large triangle that encompasses the entire diagram. Well, we just learned the fact that, or we just relearned the fact that angles have to add up to 180, so that's what the idea we're going to use here. And we're going to start with the little triangle, because the little triangle is the one we know the most about. We know 2 out of the 3 angles, so we're going to avoid the medium-sized triangle because we're missing 2 angles there, and we're going to start working with the one on the left. So we know one of them is 55 degrees, and one of the angles is 49 degrees. So we're going to add those two together and get 104. Well, the whole thing has to total 180, so when we subtract those two, that gives you 76, which is going to be our value of x. So this angle right here must be a 76-degree angle. Right, onto the y and z. If you look at x and y, they are adjacent and supplementary angles. They're right next to each other, and they share a vertex, which makes them adjacent. And you can tell they add up to a straight line. So you know they're going to add up to 180. So if they total 180, and we just used up 76 degrees for the angle that's labeled x, everything else must be y. So when we subtract that out, we get 104, which is y. So y must be 104 degrees. Well, that leaves us with z. So we're going to focus on the triangle on the right. You have a 28-degree angle that was given to us. We just figured out that y is 104. We add them together, and you get 132. And then we're going to subtract that total from 180. And get 48 degrees for z. So over here we figured out x, up here we figured out y, and down at the bottom we figured out z. And there are a couple different ways you could go about this. You could have looked at the entire triangle as a whole because you knew this was 55. You could add those together to come up with what this is, and you could add those numbers together, subtract from 180, and that would still give you the same 48 degrees. right? Either way, whichever way makes sense to you, and as long as you show some of your work, we're in good shape. All right, so that takes care of example 2. It tells you down at the bottom here that you can classify triangles by their angles and by their sides, 2 different ways. And most of the stuff you guys have seen before. When you're classifying by angles, when you have 3 equal angles, and this is actually a new word, when you're talking about 3 equal angles, they call it equiangular. Equiangular. This is sort of, it reminds kids of equilateral. Well, equilateral means equal sides, and this word happens to mean equal angles. And you can see almost the word equal right there, and almost the word angle right there. So equiangular means equal sides. And we'll put a little note here, all angles are congruent. All angles are congruent. Here we have an angle where a triangle where all 3 angles are less than 90. Well, if all 3 are less than 90, that makes that an acute triangle. We'll say all angles are acute, meaning all of them less than 90 degrees. Next one here has a box to show you that's a 90-degree angle, so that makes this a right triangle. And it's going to have 1 right angle. You notice we're never going to have a triangle with 2 right angles, because that would be 90 degrees and another 90 degrees. You'd already use up your entire 180 degrees, and you still haven't dealt with how big the 3rd angle is. So a triangle is going to have a maximum of 1 right angle. Not to mention the fact that if you drew 1 right angle and then another right angle, you'd never be able to finish that object with just 3 sides. You'd have to have at least a 4th side to complete the object and make the shape. And the last one here is going to be the obtuse triangle, because it has 1 obtuse angle. 1 angle bigger than 90 degrees. And the exact same explanation for a right triangle, you're never going to have an obtuse triangle with 2 obtuse angles in it, because both those numbers would be more than 90, so you'd already be over your 180 degree total without dealing with the 3rd angle at all. So just like the right triangle, an obtuse triangle is only going to have 1 obtuse angle at the most. Right, so that's when you classify by angles: equiangular, acute, right, and obtuse. You can also classify by sides. And here you have one where all 3 sides match. Well, when all 3 sides match, they call that equilateral. And we'll put a little note, all sides are congruent. Next one here, we have 2 sides that match, and the 3rd one does not. So that is isosceles. We're going to make a note there, 2 congruent sides. And the last one here has a short side, a really long side, and a side sort of in between, so there's no equal sides there at all. So that is a scalene triangle. Right, so we're classifying by angles there and by sides. Next time here, you'll see we'll start at page 9 and take care of the rest of the section. So we'll pause it right there and end part 1, and we'll talk to you during part 2.